Good Wednesday to you, everybody, in COM 702. Welcome to week, boom, bam, 15. You made it. And I cannot believe that my coffee is anywhere except right next to me. And once again, the favorite shortwave coffee cup. Okay, everybody. Last week's this week and then next week, and that's the end of class, folks. That's all there is, folks. In fact, last day of class is the 29th. So you've got a number of due dates and things coming up. Before we get to the questions from last week, let's just take a quick look at some things you need to be aware of. So there is posted, somebody emailed me about this. There's posted a final exam study guide. All right there in the announcements. So if you're not sure how to get ready, go ahead and click on that. In general, what you should do is go back and read through the discussion posts, read through your labs. You are not going to be asked to complete a lab during the exam. All right, that's not something that's going to come up. You will be asked about, how do you report a certain value, how properly to report a certain test, okay, that sort of thing. So you want to familiarize or refamiliarize yourself with those processes. You'll be asked about terms. You'll be asked about definitions. Some of the answers will be true, false. Some will be short answers. Some will be fill in the blank. Okay. So the exam must be completed by April 29th. Absolutely no exceptions, because April 29th is the last day of class, last day of the semester. So if you're running into any problems, please reach out to us, those in the various groups. Likewise, your final papers are due on April 23rd. So, they're due the week before. And again, a number of you already have. You've reached out to me and said, hey, I'm not quite sure what I'm doing with this. Did I do this right? And that's fine. Now, from what's today, the 19th? From today forward, I'm just, my schedule is packed. All right, so I may or may not be able to get to you in full measure, because this is the last week before we actually start grading, and Dr. Brown and I start. Well, I start grading them as soon as they come in. I think he's going to be traveling. He's going to be coming back to the U.S. But what day is the 23rd? Is that a Sunday? Yeah, that's a Sunday. So if you have any questions, it's now Wednesday. All right. I need you to chime in. Okay, so exams, final papers, we got all that. All right, let's take a look at the questions from last week, see what you did. See if we can shed any light on anything else that will be helpful for you. Question number 1, what SPSS statistics are you using in your final paper, and why is your choice the best statistics for your data? Okay, now this was a completely open-ended question. That is, there was no right or wrong answer for this question. But it's one that I want you to pay attention to. That is what you say, because here's how I will be grading you on your paper. Okay. I'm not going to be deducting points for the use of one statistical measure as opposed to another. In other words, if you don't do a big, huge factor analysis and just rotate those factors till your head spin, that lets you do, a really complicated, that is in terms of what you report, regression analysis, and all right. If you perform a t-test, and the key word here is perform a statistical analysis, all right? You've got to do something above just descriptive statistics. Okay. Yeah, technically you had to have gathered the data. You had to have inputted the data into SPSS, but to just do descriptive statistics, we're past that now. Okay, so I need a statistical measure from you. So what do you watch out for if I'm not looking for this statistical measure as opposed to that one? Here's what you got to pay attention to, and that is goodness of fit. Did the statistical test that you chose to do fit? Number one, the question you were trying to answer. So if you have a question, if you have a hypothesis that lays out causation, and you only do like a Pearson's correlation, and then you say, well, now we see that this causes that. All right. That's where I'm going to ding you, because when you have causation, then you have to move up to, the sort of even the basic form of linear regression, because we need causal statistics. We need R squared. How much of the outcome of the dependent variable is being caused by the independent variable? All right. Not just are the two related to each other in either a positive or a negative, direction, power. All right. Or again, if what you're doing is correlation, if you're doing a correlation analysis. In fact, I was just, in my spare time, I was doing some correlation analysis here this morning, and yes, I actually do that. I got up early too. I'm helping out the editor of a magazine try to sort through some questions about why the readers are doing what. Okay, so we put together a survey, and then we got all the data exported out and loaded up into SPSS. And the editor in chief wanted to know, for instance, was there any correlation between people who think that the number of emails that they get from the magazine was just right, and an interest in having the publication in print, because right now it's just electronic. Is there any connection at all? And then in the opposite of people that say they're just getting way too much email, is there any correlation to a desire to see the magazine in print? So, we ran a series, or I should say, I ran a series of Pearson's correlations. Okay, so it's goodness of fit. That's what we're looking for. And if your fit is a t-test, and you are comparing, and this is the second thing I'm going to be looking for in terms of goodness of fit, you are comparing two sets of categorical data with a set of continuous or scale data. Okay. What test should you be using? All right. So if you're using a t-test, understand that you can have categorical data, nominal or ordinal, however you set it up. And then you can have continuous data. So you can measure as the dependent variable the continuous data, and then you can measure as the independent variable comparison between two categorical data sets, gender, stuff like this. But what if you don't have continuous data and you want to do a comparison of means? What test should you use then? Chi-square. These are the things I'm going to be looking for in your paper. Do you pick the right statistical analysis? Does it has the right fit? And then do you understand how it works? That is, what kind of data goes into it. Here's a word to the wise from me to you. Be good to yourself as a researcher. Do not pick statistical measures to use that you don't understand. And yes, it's perfectly acceptable that if you've gotten this far in your paper and your head is swimming and you're like, I do not understand I don't know, whatever it is. Okay, there's no shame here. It's a MANOVA and it's just bending your brain. All right, well, back up, rewrite those research questions and hypotheses to ask intelligent questions. Don't ask, like, duh, what's the correlation to a cloudless sky and people saying the sky is blue? Like, come on. All right, so back up, rewrite your research questions, rewrite your hypotheses that are designed to be answered with tests that you're comfortable with. I know you've had a lot thrown at you this semester. All right. So that's what I'll be looking for in evaluating your papers. Okay, question number 2, what's the difference between a mediating variable and a moderating variable? And it's kind of like, how do you make a grilled cheese sandwich? The name is in the recipe. Reminds me of a Gordon Ramsay commercial. All right, Larissa, let's see what you say. A mediating variable is a variable that comes between the independent and the dependent variable, which, by the way, happens all the time in real life. It's exceedingly rare that this one thing connects to that. Even if, we did a lot of data sets that had media analysis, like watching Arnold Schwarzenegger movies and voting for Arnold Schwarzenegger. All right, well, what might be a mediating variable in there? Like, how about who you're watching it with? Are you sitting alone by yourself, or are you amongst a bunch of guys that are going, ooh, okay. That could be a mediating variable, and there are often mediating variables out there in the real world that we miss while we're measuring. So yes, Larissa, you're right. That's a mediating variable. A moderating variable is a variable that affects the strength or direction of the relationship between the independent and the independent variable and the dependent variable. In other words, it explains when or for whom the relationship is stronger or weaker. Okay, and now sometimes just like data, okay? Remember what I've said, that data does not exist out there independently, and it is in one category or another, like apples and oranges, right? You can describe the very same thing to produce categorical data or continuous data. Like, I think I gave this example once in a video, so if I'm doing it again, please forgive me. Like eye color, okay? Or sex. That's an easier one, because you could just say, what's your sex? Male, female. Boom, done. Very clear, nominal, categorical nominal data. Wham, pow. Okay. Or, given the crazy climate we live in, you could set up a Likert scale and say, please respond to the following statements based, choosing a number from the scale from, 1 strongly disagree to 5 to agree. Okay, so there you go. Then the question is, I identify as male. I identify as female. All right. Now you're going to get continuous data. Okay. So you're asking about the same thing, sex, but you're just asking about it in another way. And you could do that with eye color. You say, what color are your eyes? And you could have blue, green, brown, black, and hazel. I think I've covered the major eye colors. If I've missed one, pardon me if that's your eye color. And so there, boom, you could just have those 5 categories set that they click the boxes, and this is categorical data. It's ordinal in terms of how you've set it up, or you could set it up as a continuous, as a Likert scale question to get continuous variables. Say, answer the following on a scale of 1 to 5. My eyes are blue. Well, strongly disagree, because my eyes are not blue. My eyes are brown. Okay, well, now you have continuous data. So the same thing goes for mediating and moderating variables. This depends on how you classify them. So back to the Arnold Schwarzenegger, the mediating variable could be something that amplifies between the independent and the dependent variable, or it could be something that's on the side and strengthens the direction. And that could be the guy attending the woo-ha, crowd as he watches the video. All right. Just depends on how you pull it down. Okay, question number 3. In addition to chi-square, explain other non-parametric statistics you could use to evaluate nominal and ordinal data. Okay. And there are a number of them. Amanda, let's take a look at what you said. Looking through the books and outside research, I found at least 3 non-parametric statistics to be used to evaluate nominal and ordinal data. Will Coxon, this test compares the median of the 2 independent samples. Kruskal-Wallis, H. This test compares the means of 2 or more independent variables. In the Friedman test, this test compares the means of 2 or more related ordinal or continuous data groups. Okay, that's good. Tim, did we do anything from you yet, Timothy? Let's pick you. Let's see. You had a whole bunch here. Look at this. Moods median test, which compares the medians. Whitney U test, which I have used, compares sum of ranking scores. Will Coxon match pair assigned rank test, compares magnitude and direction of the difference between distribution of scores, et cetera, et cetera. Okay. And again, this is one of those questions that's like, all right, go out and find it and come back and report. Okay, good job to the both of you. Question number 4. In your own study, what are 1 or 2 measurement errors that you will encounter? Now, notice how this question is worded. Not that might you encounter, that you will encounter. And here's something else that I'd be looking for in your papers. Okay? If I can see that you have errors, okay? Especially in your measurements. And then you make a statement like, this is true for the whole world. I'm going to ding you. Okay, so I know we pulled something from you before, but let's go back to you again, Larissa. So for my study, I think I will, what I think I will encounter is, number 1, sampling bias. I think, Amanda, you had a similar response. The non-probability sampling method used in the study may not be representative of the larger population, leading to sampling bias. This means the study's findings may not be generalized to the broader population of individuals who have not visited the U.S. Disney Park in the last decade. All right, that's beautiful. Yeah, beware of that. And how do you account for that? You go, oh, no, I have to find people that have not visited the park. No, then just don't say that whatever you conclude has this fantastic external validity. That is, it applies to everybody in the U.S. of A, because it doesn't. And that's okay in statistical research. Back again to my, jumping up, very excited to do some statistical analysis for the editor of this magazine. All right, one of the questions that they're trying to get at is, would people be interested in a print version of our magazine? All right. One of the drawbacks of the research that they designed was they only asked subscribers of their database. Now, that's not a criticism, but that's a limiting factor if you're trying to, noodle out the question of who would want to buy a print magazine from the larger population, because people that have already self-selected, like going through the gates of Disneyland, they're already self-selected in they're in a data pool that's not representative of the entire United States. They, what they have to say may or may not be applicable to everybody else. Okay, so just say so. All right, you can put that in your limitations. Okay, measurement bias. The study relied upon self-reported data, which may be subject to recall or social desirability bias. Recall bias occurs when participants do not accurately remember or report their experiences. Social desirability bias occurs when participants provide answers that they believe are socially acceptable or desirable, or that you, as a researcher, if you give yourself away, that they think they want, they're going to answer what they think you want. They want to please you. Socially acceptable, desirable, rather than their actual beliefs or expression. This may result in an inaccurate or biased database. And, the first one that you mentioned here, Larissa, raises an interesting question. I was reading a paper on this. I think it was even last year. And that is, given that there is, recall bias and recall blurriness in how people remember, or how often they remember they actually did something like go to the gym or whatever, that raises an interesting question. And you can, look, so long as you discuss this as a researcher, you're just honest with your audience. The interesting question is, what is it that you would be measuring? Let's say you were asking about, you were taking a look at the relationship between someone's body mass index, their BMI. This is the ratio of their fat to muscle vis-a-vis their height, their body mass index, and how many times a week they walked vigorously. All right, I'm pulling two things out of the air. You're going to do a regression analysis, and you're going to see, how the one drives the other. Okay, so you're getting both continuous data for both of those. Okay, so you ask them about, how many times a week do they walk vigorously? All right. Well, What is walk vigorously? Does that mean like, they walk around the office to their work, but they spend 90% of the day sitting? Does that mean that they walk vigorously as they walk the dogs, or they go to a gym and they walk around a track, or what? And then when they're thinking about how many times do I walk vigorously, what is it that they're thinking about? Are they thinking about vigorous walking as in so many steps per so many minutes? Or are they thinking about, dang, this feels vigorous to me, because maybe their body mass index is really high, that is, they're overweight. So even moderate walking feels vigorous to them. So the first question is, what are you measuring? Okay, so there's this subjectivity that's baked into it. Then the second question is, when you're asking them to recall what they did, let's say you're testing it over the last 6 months. You're asking them about vigorous walking over the last 6 months. Okay, what are you testing? Are you testing how many times they actually walked vigorously, or how are you testing their impression of how many times they walked, which can be an important part of your study, because you can say that people, you could do a study in which you tracked what they believed they did, and then some people in the study, you actually had them wear step counters, and then juxtapose that data of what they believe they did against what the step counter says they did. So it's perfectly okay if what you're measuring is what they think is going on, right? As long as you say what we're measuring is the variance between what they think is going on and what actually is going on, then how does that result in their body mass index? And there are some studies, I'm not just pulling this out of thin air. There's studies like that ask people to recall, what they ate in a day, and then kind of estimate their calories. And then they juxtapose that against where they had people keep very careful food diaries and weigh out everything that they ate and write down what it was. And then there was a caloric content calculated for total daily input. And now, don't quote me on this, but as I remember reading the study, that it's something like people underestimate the number of calories that they take in every day by something like 200 to 300 calories, which doesn't seem like a lot. But if you add it up over a week, that's a lot. So it's all right. It's all right if, you get some wonkiness in measurement, just so long as you understand that can happen. And just tell your readers, there might be a sampling bias in here. There may be a measurement bias, because I'm asking people to remember from a long time ago, or I'm asking them a question that and look at other people, look at other researchers. Are you asking them questions that tend to elicit highly subjective responses? Like, what does being religious mean? I mean, if you look at that data, holy cow. I mean, the people in the country who say they are religious, that number is really high. But the people who go to church, in comparison to that number, is low. So we have to say, okay, so when you're asking, are you religious, do you mean how many times do you attend a church service during the week? Or, you go home and dust off your angel figurines? I mean, what is the survey taker thinking about that? And it's okay, if you get those biases, just so long as you account for them and you don't cock-a-doodle-doo, this is tremendous external validity, when it's not, because the sample size is not representative of the population. Or there might be, recall problems or attitude bias baked into some of your questions. Okay. All right, everybody, we're keeping it short today, 23 minutes. End of the semester. I'm going to miss you and talking about quantitative research and statistics. Because, I'm one of those strange sorts, like your dental hygienist. It's like, you like sticking your hands in people's mouths, that I like this material. I like quantitative research and being able to help you understand it and like it better. Okay, everybody, remember, as we especially go into finals and you're finishing your papers, you're taking your tests, I know you're carrying a lot. So I'm thinking about you. I am praying for you, and I will see you on Blackboard. God bless. Bye-bye.